linear functions, we've already done that. How to use average rate of change to identify linear functions. Rate of change means slope, which means we're going to use slope to talk about how we can tell if something's linear or not without looking at the graph or maybe the equation. We're going to talk about increasing, decreasing, or constant, which we just did on our last test, but maybe in terms of linear graphs, and some story problems. So let's see what we can get through today here. We have a half hour. So this, I don't even know why I put this on here, because I feel like we all should know how to do this, but just to kind of start back slowly after a week off. Determine the slope and the y-intercept and graph the function, right? Linear functions are when you don't have an exponent on x. Slope-intercept form, it's already in slope-intercept form. So Aaron, tell me, what is the slope and the y-intercept of this graph? 2 is the... And the y-intercept is 3.
Oh, I was looking for 4.
And that's how we graph. If it's in y equals mx plus b, we know that we graph the y-intercept first. So I go up to 3 on the y-axis, and my slope is rise over run, up 2 over 1, up 2 over 1. Blah. Good? What would you say about this graph? Increasing, decreasing, or constant? On a linear graph, is it always going to be increasing, decreasing, or constant the whole time? Right, a linear graph can be increasing for a while and then decreasing for a while because it's not linear anymore. Right, like it's always one or the other. Keep that in mind as we go through this. Average rate of change, aka slope. Right, we say slope so much, sometimes we forget what we're talking about when we talk about slope. We're talking about how fast the graph is changing. When we say it has a slope of 2 over 1, we're saying it's changing at a rate of up 2 units over 1 unit at the, or up 4 units over 2 units. That would be the same thing. Linear functions have a constant average rate of change. And that's kind of what I was just talking about, meaning that when we're talking about a linear function, it changes the same over and over again. The slope is the same the entire graph. And for y equals mx plus b, we would say the average rate of change of that we already know is m. So just be aware that this book is going to say average rate of change opposed to slope. And it's the same thing. It's just a fancier way of saying it. Feel like that I made you fill the blank in. So, on your homework today, you have some problems like this that say, determine whether the given function is linear or nonlinear. If linear, find the slope. We could actually graph these points and see if it makes a straight line, but the idea is if we just look at the rate of change, if it's linear, it's going to change the same the whole time. If it's not linear, then the change in between each point is going to be a little bit different. So, do you agree that the x's are going up by 1 on this chart? So if the x's are changing by 1, we want to look to see what the y's are changing by to see if it's constant. From 13 to 10, what's happening? It's gone down by 3, so I'm just going to put a minus 3 out there just to kind of say what's happening. From 10 to 7, what's happening? Could I go all the way down this list and say that I'm subtracting 3 every time to get to the next value? And I'm subtracting 1, adding 1 on this side. Right? This side I'm going plus 1, plus 1, plus 1. Is that a constant average rate of change? It's changing the same every time. So I can say, without graphing it, without seeing an equation, I can say this is linear. And I can even go as far as saying, what is the slope or the average rate of change of this graph? -3, because this is changing by 1 every time, we could say the slope, we know the slope is rise over run, or y's over x's, that the slope, or the average rate of change, is negative 3 over 1. If you got stuck, could you make a little graph? Definitely. But the idea is you shouldn't have to make a graph every time. So what about this one? Again, always kind of be aware of the x values. I always like to make sure my x's are going up by 1, or that they're a constant change on this side before I start looking at the y's, but these are just like those over there. What about on this one? What happens from 1 to 7? What happens from 7 to negative 2? If you find two that are not the same change, is that linear? Not linear. Or they're saying non-linear. If it's not linear, can I find the slope of it? No. Good with that? Again, not something like earth-shattering, but maybe looking at linear functions a different way than you did in Algebra 1. Increasing, decreasing, and constant. Because linear functions have a constant rate of change, they are going to either be always increasing, always decreasing, or always constant. And the slope will tell us that, right? If your slope is positive, remember that that means your line kind of looks like it's going up. So if you have a positive slope, what do you know about that graph? Is it increasing, decreasing, or constant? Always going to be increasing. And if you have a negative slope, doesn't that look like your line is going down? Which means if you have a negative slope, then your graph is always going to be decreasing. And if you have a 0 slope, what does that line look like? Which means that line is always going to be constant. Which means, unlike what was on your Unit 2 test, where you had to look at each section of the graph and give the intervals, these graphs are either going to be increasing, decreasing, or constant the entire time. They're not going to be split up like that one on your test. Okay? Fine. So it says determine if each function is increasing, decreasing, or constant. You shouldn't have to graph this. You shouldn't have to make a chart of it. You should just be able to look at this, find the slope, and the slope determines if it's increasing, decreasing, or constant. So Angel, number 4, what would you tell me about that line? Increasing, decreasing, or constant? Because the slope is negative, right? Negative slope means I can say this is decreasing. Which means on your homework tonight, there's a lot of questions that don't take a lot of work, right? It's just understanding what it's asking and being able to answer it without really doing a lot of work. Aaron, number 5. Increasing because slope is positive. What about number 6? Daniel. Because? Because it's one number. Has 0 slope, right? You could think of this as like 0x plus 4. There's no slope there. Constant. On a whole homework quiz of that tomorrow, right? No. Now let's get to the story problem. We got story problems now. Built you up so I can tear you down, right?
Is there a song about that?
I don't know. Supply and demand. Supply and demand, if you're taking econ or you're in econ, you probably talk about supply and demand, right? Supply is the amount of product a company is willing to make available for sale at a given price. Demand is the amount of product that consumers are willing to purchase at a given price. When I was in econ, all my econ teacher ever talked about was supply and demand with gas prices, because I don't know why we are obsessed with gas prices, but that's all I can tell you I learned in econ was supply and demand with gas prices. The equilibrium price, who's an econ that can answer this question? What is equilibrium price?
It's when supply and demand are equal.
When supply equals demand. Which means if they ask you a question to find the equilibrium price, and they give you an equation for supply and an equation for demand, all you have to do is set them equal to each other to solve for that equilibrium price. All right, because you know, at a certain price, people aren't going to buy it anymore, so that makes the demand go down. So, let's look at a problem like that. Aren't you so glad I printed this for you? Oh, gee. Suppose that the quantity supplied S and the quantity demanded D of t-shirts at a concert are given by these functions, supply and demand, where P is the price of a shirt. Part A, find the equilibrium price for t-shirts at this concert. What is the equilibrium quantity? Should I leave it empty space for the next one blank? Okay. So why are we doing these problems? Because these are like applications of linear equations. These are both linear equations. So we're saying, what can we do with linear equations? People that sell things, economists, they really do use supply and demand equations. So equilibrium price means I'm just going to set supply equal to demand. So I'm going to say negative 200 plus 50p equals 1,000 minus 25p. And I'm just going to solve that equation, which means get the p's on one side, the other numbers on the other side. I'm trying to find a price here, so probably shouldn't be a negative number. So if I add 25p to this side, and I add 200 to this side, I would get 75p equals 1,200. Do you agree with that? And if you divide by 75, you get 16. So find the equilibrium price for t-shirts at the concert. $16. Is that a reasonable answer? $16 for a t-shirt at a concert? I think that's reasonable. If you would have got like $1.50, probably not a reasonable answer. $200, probably not a reasonable answer. So story problems, people don't like story problems, but you can at least see if your answers make sense to the problem. It also says, what is the equilibrium quantity? What do you think that means? How could I find how many t-shirts could I sell at that equilibrium price? Plug it in. If I plug that into either the supply or the demand thing, should I get the same answer? We just found the price where they equal the same. So all you got to do to find the quantity is take that and plug it back into one of them. So if I did S of 16, my S can look like a 5. That would be negative 200 plus 50 times 16. And I would get 600 shirts. Should be the number that I could sell for $16. Goodness gracious, how are we supposed to do this? There's no room to do this problem.
Whose fault?
Fine. Determine the price for which quantity demanded is greater than quantity supplied. What do you think we do with that? Demand greater than supply. Are we going to end up with 16 again? So could we maybe go ahead and infer that it's going to just be at price greater than $16? Or is it going to be less than $16? We better just do it. I was trying to skip. Alright, let's write it out. Quantity demanded, so we better switch it around. So 1,000 minus 25p. Demand is greater than supply. I just want to check my, it's definitely going to be 16. We just got to figure out if it's going to be flipped around. If I subtract this over here, I'm going to get negative 75p is greater than negative 1,200. So because I have to divide by the negative, I'm actually going to get, when the price is less than $16, right, that's why I wanted to write, that's why I stopped myself from just jumping to the answer. And the quantity demanded is greater problem and then actually go out and see if it works.
Let's go on a field trip to
Let's do it. So, less than $16 would be the answer to this. Not $1,600. We'll put a decimal there. I don't know. We should ask Miss Rose that question. I don't know. I kind of just always use the equation they give me, and I never think about it. But this is kind of more just a thinking question, not a lot of math going on here. What do you think will eventually happen to the price of T-shirts if quantity demanded is greater than quantity supplied? What happens? What happens every time they say there's a shortage with gas? That I have to go back to my email days. Price goes up, right? So if people want more shirts and they sell out, then they can make the price higher because it's like, I only have 10 shirts. This is only all I have. They can charge you $30 a piece for them because you're like, oh, there's only 2 left, right? So yeah, price goes up. Price goes up. All right. Straight line depreciation. I find this to be a little silly, but it says some companies depreciate their assets using straight line depreciation so that the value of an asset declines by a fixed amount each year. If a car costs $28,000 with straight line depreciation over 7 years, we kind of want to say, like, what would the slope of that be? Because it's a straight line. So if I had $28,000 and it says straight line depreciation, then we know it's going to go down at a fixed price each year. So we can say over 7 years, what's that going to equal? What's 28,000 divided by 7? 4,000. We can say that the price of this car loses $4,000 per year in its value. I don't know that I agree with this, because that's saying after 7 years that car is worth $0. I don't know how applicable that is to life, but what? Maybe to a dealer, you're right. Because sometimes they say trade in, like you're actually like paying them money to take your trade in because it's not good. Yeah, like I feel like it's gonna kind of bottom out at some point and not be worth a lot, but is it really gonna be 0? So we're just gonna go with it. If it says straight line depreciation, we're gonna say it's at 7 years it's going to be $0. So let's do a problem using it, and I think you can kind of graph this to tell us too. It says, suppose that a company has just purchased a new computer for $3,000. The company chooses to depreciate the computer using straight line method over 3 years. And this might be used more for like the company. After 3 years, they're going to say they need to upgrade, so it's worth nothing to them anymore, even though I feel like you could get something out of it if it still works. But it says, write a linear model that expresses the book value V of a computer as a function of its age X. And again, a lot of issues with story problems is knowing what it's asking and being able to answer the question that it's asking. First of all, let's just think about this. If it's $3,000 to begin with, and we're using straight line method over 3 years, we can kind of say that the rate of change, it's losing value. How much each year is it losing? Yeah, because it's $3,000 over 3 years, so we can say that it's losing $1,000 per year. That's the rate of change, or AKA the slope of this problem. Okay, so if you're saying something's happening per year or per day, that's the slope of the problem. So we want to think about, could we write a linear equation showing that we could find the value of this computer at any time? So write a linear model that expresses the value V. So instead of doing y equals, they want us to use V equals as a function of its age x. So normally we do like mx plus v, right? B would be like the y-intercept, where it starts. How much does this computer start with? Valued for $3,000. So I'm going to put a plus 3,000 out here. And I want to show that it's losing $1,000 per year. So I need to put X in there. Can I just put 1,000X here? Would that work? Negative 1,000X plus 3. And see if that makes sense. If we plug 3 in there for its age, would that give me 0? If I plug 0 in there for X, I would get that it's worth $3,000 the day I bought it. So every time you do this, your linear depreciation will be your slope. How much it starts with will be your y-intercept, like every time. And so, let's look at these other parts of this. Oh my goodness. E, oh my, what is the question to part E? This is like calculus. What is the implied domain of the function? The domain is the x values. So the domain is time. So can I have a negative time? No. Could I have time equal 0? That would be like the day we start. So I think the implied domain starts at 0. And when is this function over? Like, when am I to $0? 3 years. Because after 3 years, we're not going to say it's a negative amount, right? So we're going to say the implied domain is from 0 to 3. And it says implied because they don't really tell you that, but you're really just looking at those 3 years. Graph the linear function. I'm going to make a really tiny little graph here. Since my domain is from 0 to 3, is it okay if I just make a graph? Like, just like the first quadrant? And I'm just going to put 1, 2, 3. And what should I make my y-axis go by? Ones?
Twos.
How about 1,000? Right? If I'm going to graph negative 1,000x plus 3,000, do you agree going by 1,000 is probably a good idea? 2 would be terrible. You'd have to go to 3,000.
It's a lot faster than that.
It should be a straight line. You could just pick points here without even doing slope-intercept form. At 0, how much was that computer worth? $3,000. After 3 years, how much is it going to be worth? Nada. Right? You could do the slope. Down 1,000 over 1. Down 1,000 over 1. Down 1,000 over 1. Straight line depreciation means it depreciates in a straight line. It's a fancy name. If you have the graph or the equation, you should be able to answer part D and E. But again, it's kind of asking you to, giving you different values, sometimes giving you the X, sometimes asking you for the Y value. So part D says, what is the book value of the computer after 2 years? We could plug 2 in up here. We could look on here and say, after 2 years, how much is it worth? $1,000. So they give you the X value on that and ask you for the Y value. But on E, they say, when will the computer have a book value of $2,000? $2,000 is after 1 year, so 1. Is there more to this, or that's it? Oh, look, I gave you a blank spot on that one to do this problem. Now that you flip it over and you see it. We'll definitely do more story problems when we get to quadratic stuff too. So as we go on and add more to this, we want to make sure we see where we're talking about a linear equation or a quadratic equation. 11 problems on here, all mixed up. Some are just, is it linear? Is it constant increasing or decreasing? Find the average rate of change, which is find the slope. Some are the story problems. So try these. We'll go over what questions you have tomorrow. We'll probably take a homework quiz and then go on from there.